Hello, welcome to Houdini 3D Lighting Tutorial Part 2. Sorry if my voice sounds a little bit, how's it going in this? I've just been kind of sick, but hopefully you can all still understand me fine. So anyway, let's dive into it. So basically, we're continuing on from what we had last time. So basically, we've got this electrode sort of thing, just arcing down some bolts to the ground. The bolts are animated, but, they're kind of just stuck to these, like, static points from coming from the scatter up here. So basically what we want to do is have these bolts kind of flicker on and off, like jump to different points, every, few frames. Make the whole thing look a little bit more energetic. So the first thing I'm going to do is just hit W, and that'll switch it into a into smooth wireframe mode, and then I can hit Shift W to change it into a regular old smooth shaded mode. So that's W toggles wireframe and Shift W toggles smooth wireframe. So it's probably a good one to remember. I'd say, probably the most powerful hotkey in all of Houdini. So definitely remember that one. So basically we've got this scatter up here. And before, we use this force total count to control the number of bolts. And it's got this other setting a bit lower called global seed. And basically the global seed, if I zoom in here a bit, you can see it's basically going to rescatter the points in a different position. And go over to scatter 2, which is the ground plane scatter, and if I do the global seed here, you can see it does the same thing. So just like how the first time we went force total count, copied the parameter, and pasted it to the force total count on scatter 2, we'll do the same thing here with global seed. So copy parameter, paste copied relative references. So now, whenever we change the global seed for scatter 1, that change is going to be reflected in scatter 2. So changing it essentially is kind of re-spawning the bolts into a new position. So I think this is kind of good, except we want this to happen, every like 10, 20 frames or something like that. If we play it back, it's not going to do it. So we can do this with a little expression. So basically, instead of just putting a straight up number in here, we can do something like $f, which is the global variable for current frame. So if we play back now, it's going to give us new bolts on every single frame, because the value of seed, if we just click on it, we can see the value of it. You've got to scrub through to make it update, but you can see here now it's changing every single frame. It's going to be the same number as the current frame. So, that's an alright look. Might be what you want, but I think that's kind of hectic. I want a little more control over this. So, to do this, I'm going to first multiply it by 0.1. And so now, if I just click on here, you can see it 0.1. Oh, whoops, 1 times 0.1. I want $f times 0.1. My bad. So yeah, now as I scrub through, you can see that the value goes up at 1/10 of the current frame. So there, frame 20 is 2. Frame 25 is 2.5. So on. So this hasn't really changed anything, because the input seed is still changing every single frame, even though it's now just like 1/10 of what it was. What we can do to this though is use another expression. If I just click on it again to turn it back into the expression kind of mode, is I can just chuck this in brackets and then type in int at the front. So basically int means integer, and all that means is it's going to get rounded down to the nearest whole number. So, 0.5 is going to be rounded down to 0. 0.9 will also be rounded down to 0. 1 won't be rounded down, because that's the next integer. So you can see now, for the first 9 frames, it's the same thing. And once we get to 10, only then does the seed change. And then it will stay like that for another 10 frames. So if I just click on it here to see the value, you can see basically 0, 1, 2, 3, so on. Now it's changing a little bit less frequently. That's kind of good. I might make this even smaller number, like 0.05. And we'll play that back. So now it should be changing every 20 frames. So that's kind of cool. Starting to get something there. I think it might look good if all the bolts weren't changing at exactly the same time though. So what I might do is make a merge, and I'll just put it here after the add, before the color. And then I'll grab everything above that, move it over to the left, copy, paste, and then I'll plug this also into the merge. And now it's going to look exactly the same because we're basically merging two identical things together. But let's say for this one on the right, we'll change the amount that it's multiplying by. So I'll make it something like 741. And I made it a number that deliberately will not multiply into this number, which means basically that they're not going to change on the same frame ever. So now if we play that, so yeah, that's starting to look something a little more interesting. I'll maybe also turn down the number of bolts in this one. That's kind of cool. You can see they're pretty similar there for the first frame. I think the way we can deal with that is at the moment it's probably got the same seed for the first few frames. So we can just like add some kind of random amount to it to just change it completely. So go like 42 is a good number. Meaning of life, the universe, and everything. So there, you can see for the first 10 frames, they've still got a completely different seed now. So this is alright. We could, continue to add, more copies of this again and again and again, giving us kind of more like layers, if you will, of this lightning, kind of flickering on and off, but, that'll get a bit heavy. And it's probably not the solution with the most control. So let's delete this. Let's try and do it procedurally with just a couple nodes. So I'm basically going to introduce two new nodes here. So the first one is copy. And copy has sort of two main functions. So I'll just get rid of this merge and I'll put the copy here instead. So the first use of the copy, if I just look through it. Oh, in fact, no, I don't need to look through it. The first use of the copy is this number of copies up here. So if we slide this slider up to 5, now basically we've got 5 copies of all these bolts. If we look in the geometry spreadsheet, you can see each copy is adding a whole bunch more bolts. But it's exactly the same bolts in every case. We can add a translate to each copy. So then now as we scrub it up, it's basically going to copy it, in one, with that transform every single time, like accumulative. We can tick that off, and then, they'll all just be transformed there. We can give it a bit of a rotate. So every copy is going to be a bit rotated now. So that's all well and good. I'll just zero these back out again. Whoops, 0 point. Just 0, thanks. Alright, and the other use of the copy is we have this copy to points. So that's this second input. So template to copy to. So we can go, I might just actually, let's do this with like a cube or something just to make it a little easier to see. So I'm just going to go box, plug this in here. So yeah, we've got 6 copies. We can, translate them, rotate them, scale them. And I'll just ghost other objects. So yeah, that's basically how that version of it works. Put it back to 1. The other version, if we make a sphere and change it to polygons, uniform scale it back up. I'll just use that sweet hotkey we learnt before, Shift W. Now you can see the wireframe. So when we plug this into the copy, now you can see the cube has been copied to every single point on the sphere. So basically that's the other use of the copy, is that it will take whatever's going in input left or input 1 and copy it to every point that's coming in from input 2. These things kind of like stack, if you will. So if we turn up the copies here, so now every single copy on each point is also going to be copied, for 5 times with those translates, with those rotates. So yeah, the two things kind of stack together. We're not going to use it like that though. it's getting a little hectic. So yeah, zero these out. And put this back to 1. So yeah, that is the 2 uses of copy. So the other thing I'm going to do is make an add. And earlier we used the add to go polygon by group, and that basically added the points on the sphere to the points on the ground, creating our like arcs that we turned into the lightning. Add also has another use. Well, like it has a bunch of uses, but here's one more of the uses. If we just turn this to hide other objects, you can see with the add, if we look through it and tick this tick box on, now we have a point. Look at point number. It is point number 0. So, we can turn up the number of points. Doop doop. So now we have 3 points. They're all at 0, 0, 0. But we just want 1 point for now. So we're going to plug that into the copy. And if we look back through the end, and I'll just turn point numbers back off. Curse this again. So now basically what's happening, instead of this kind of existing as a solitary thing, a whole lightning effect, now basically we have it being copied 1 time to this 1 point. And since the point's at the origin, it's being copied to exactly the same place that it already existed at. If that makes sense. So, I could move this point along, and now it's being copied to wherever the point is. But we just want it copied to the origin. So, sorry if I'm, over-explaining this a bit. I just, want to try and make it totally clear what I'm doing here. So, what I can do now is make another copy. So, yeah, now we have this whole thing pretty much being copied 1 time to this 1 point. And we could move the point, and then the whole thing would be copied to wherever that point is now. But we just want to leave it at the origin. So basically, it will stay exactly where it was. So great. Basically, now we've created a copy of that thing. It is exactly the same as when we hadn't created a copy of it at all. Why is this useful? Well, now we can use something in here called the copy stamp. And what the copy stamp allows us to do is create a variance, if you want, or a variable on anything that is being copied. So each copy will be the same, save for one thing, which we're going to stamp differently. And the difference is kind of defined by the incoming points. So I'll just demonstrate this. So we can go something like variable 1. We'll call this rand spawn. So this will be the random spawn time for every single bolt. And we'll just start with rand at ptnum. So what this does, the rand expression, rand, is going to take whatever's in here as a seed and create a random number between 0 and 1 based on that seed. So let's tick off here. So now we have this variable rand spawn, which is going to be something different for every single incoming ptnum, or every single point number. So, at the moment we've got, you can slide this up to 5 incoming points. So now we have point numbers 0 through 4. So that's cool. So how do we stamp something? So I'm just going to copy this rand spawn. So I'll just come up to the scatter here and right click on the global seed thing we've got and go edit expression. Just to, this is the same as what we're typing in, just brings it up in this little text editor, makes it a bit easier to see. So I'm going to start this on a new line. So a new expression is copy. No? My bad. Stamp. So you write stamp, and then it kind of tells you here, string scope, string token, float value, that's a bit confusing. Basically, what that means is the first part is path to our copy SOP, or copy node. So it's in slash obj, that's here, then slash lightning fx, the next bit, and then it's copy 1. So copy 1. And I'm just, whenever, I type something and it kind of comes up underneath there, I'm just pressing down to highlight it and then enter. And then all of that is inside quotation marks, which kind of says that it's a path. So that is the string scope. Next part is the string token. So that is our variable name, which we called randspawn. And then last, separated by another comma, is just some amount for it to be if it can't find another value. So kind of a default value. And we'll just say 0 for that. So close brackets. And that looks good. So basically what this is doing is creating a random number using that rand expression from the copy. Random number between 0 and 1. And that number is going to be different for every single copy that we make of this. So if we highlight this, we'll just cut it and then paste it here instead of this 0.05. So paste and apply. And that looks cool. So I think it's doing that same thing where the first 10 frames are going to be the same, but after that, nope. What have I done wrong? Always gets me. Stamp inputs, this little tick box here. So basically you've got to tick this on for the stamp to be applied. So whoa, check this out. So yeah, now I've got, this is pretty hectic again, but now I've got basically all these different kind of like copies of our original incoming points. I might just turn the number down to make it kind of easier to see. And you can see some are lasting a little longer than others. So, you know, this is alright, but it's still a bit kind of hectic. I'd like to have a little bit more control over it than just being a random number between 0 and 1. So let's see what else we can do. So yeah, here I'm going to create a point wrangle. And so this is basically the same thing as the point vault that we used before. Except whereas this is kind of just, you know, like spaghetti noodles of like visual vex, if you will. The point wrangle, is pretty much just written vex. So blah 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 blah. We type it in instead of using the visual spaghetti noodles. But you can use it either way. And I'll link in the description a scene file which has both methods, so you can kind of like see the difference between the two. But yeah, this should keep it pretty simple. So basically we're going to start by creating a new attribute, and we do that by saying @ and then we'll call this bolt life, and then we'll say equals rand at ptnum. So exactly the same thing we did before, and then any line of vex needs to be closed with a semicolon. So there, got at bolt life equals rand at ptnum. And so yeah, since, you know, at bolt life doesn't exist, it's going to create it. So see over here, it's created that amount, and it is equal to random amount between 0 and 1 for each incoming point number. So now in the copy, instead of saying rand at ptnum, we can just use this expression, sorry, this attribute here, bolt life. So I'll just paste this in instead. And you can see this does pretty much the same thing. So yeah, I've got some bolts lasting a long time, some lasting way less time. And if I just go back to the copy tab here, I can, you know, crank up the number of copies, turn it right down if I want. I think we might try and have a little control over the seed here. So instead of just being rand at ptnum, I'm going to add an amount to it. So basically this is going to change the seed by some amount for every copy. So here's another little expression. We'll go chf, which is channel float, and open bracket, quotation marks, and then we'll just call it, so something like life rand seed, quotation marks, close bracket. And just stop this playback for a second. Okay, so we can see that this hasn't really done anything right yet, but if you click this little button over the side here, this kind of like plus with a slider. Like that is not at all what I thought it was, except now that I know what it does. Guess it kind of looks like that. So click that. Now we get the slider down the bottom. And so what the slider does is basically represents whatever value we have typed for this. So CHF, channel float, and then it's called life ran seed. So we could have also done CHV for channel vector. That would have given us 3. Or CHI, which would have given us the power of the dragon. No, that would have given us integer value. So basically whole numbers. And there's a bunch of other ones like you can see channel 4 CHR. I assume that is to do with degrees. I don't know. Ramp. I don't know, there's a bunch of ones. Also, if you look up in the scatter 2 here, you can see this is using the same thing. But then it's a path to another node, scatter 1, and then endpoints, which is that one's seed, that one's, you can see under parameter endpoints, or NPTS. So basically that is the value bound to like this slider here. So anyway, don't get too sidetracked. So basically now we have this slider which changes the amount in the rand. So it basically changes the seed for the rand. So if we play through, you can just add different amounts to this. And, you know, try to find something that we like a bit. This is still a bit of like a imperfect way of doing this, but you know, the lightning's pretty kind of chaotic effect. Like this looks a bit better. It's got a few like slower, kind of longer lasting ones. Looks alright. Yeah, that one's kind of good as well. So we got some pretty fast ones. So anyway, this looks alright. Let's add another line to this. So this line will be on the outside of everything. So after the final bracket, we'll go multiply by, and then we'll use that channel float expression again. Open bracket, we'll call this one life mult. Quotation marks, close bracket. And you can see straight away that has kind of become 2 static bolts now. And that's because without defining life mult, without like hitting this button, making the slider, it's just 0. So basically we have this whole thing that we set up just multiplied by 0. And anything multiplied by 0 is just 0. So hit this, scroll it up a bit. So let's take a look at what's happening here. So basically we have a random amount between 0 and 1, that's this part here, and then we're multiplying it by whatever amount is in this slider. And then where is this value going? In the scatter. So going in the int. So remember when we multiplied by 0.1, it would change every 10 frames. When we multiplied by 0.5, it would change every 20 frames. So pretty much the lower the number that we multiply by, the lower this is, the longer the bolts are going to live. So check this out. If we go into the life mult now, we can go really fast as we bring this number down, closer to 0, multiplying it by smaller and smaller numbers. Can make the bolts last for a long time. So that's quite short. Bit longer. Yeah, I think something like this looks kind of cool. Maybe make it a little faster. And yeah, we can just keep changing around the seed here. So this looks alright. One thing we could do is just turn down the number of bolts in each like group. So I'll turn the force total count down to 1. And so now each copy of it only contains 1 bolt, if that makes sense. So here we're copying the bolt 1 time, 2 times, we've got 2 bolts, and each one now has a random life. Crank it up a bit. So that looks alright. Although, to be honest, I kind of liked it when we had like layers, if you will, of bolts. So, like 2 or 3 bolts changing at the same time. Still not all of them changing at the same time, but 2 or 3, because it kind of looked like the energy like dissipated in one area, kind of like jumped to another area. It's like a bit less kind of chaotic than this. So let's take a look at doing that. So we're just going to create another attribute down here. And we'll call this I at bolt count. And the reason it's because we're defining a new attribute here, we're saying that this one's going to be an integer. So you can do the same thing and say v at bolt count. Just to demonstrate this, I'll just go equals, and then for a vector we'll do swirly brackets, and then it's like number, comma, number, comma, number. And then close swirly bracket and semicolon. So now if we look in the geometry spreadsheet, we basically have this one called bolt count, which is bolt count 0, bolt count 1, bolt count 2, because it's a vector. And if we didn't define it as a vector, it would just be a float. So that's what happened with bolt life, it's just a float, or we can do I, which means it's an integer. Oops, and it does not like that because integer cannot be 3 things, but it can be a 0. Or a 1 or a 2. You can see even if I do like 1.5 for this, it'll work, but it'll just get rounded down to 1. And we get this kind of like yellow, like wah wah around the wrangle there. So yeah, the way we can kind of control that, if we just chuck an int, that expression we used before, to round things to the nearest integer around the whole thing. Or another one we can use, because integer always rounds things down, but things actually naturally want to round to the nearest whole number rather than the nearest lowest number. So we could do rint, which is round integer. So basically now if we did 1.5, you can see it goes to 2. Whereas just plain old int would go to 1. So yeah. So go rint. And I don't know why it has a problem with that. Anyway, it doesn't matter, because, it still works. I guess I'll go int, just to get rid of the error. Whatever makes Houdini happy. So anyway, let's move on. So, bolt count, we'll just make this random as well. So, get rid of the 1.5. We want this to be inside the brackets of the int. So I'll just make some space here to make it clear kind of what we're doing. We'll go rand at point number. So again, random number between 0 and 1 plus, and then I'll just copy this, channel float life rand seed, and paste it down here. So now we could use this random seed to control the number of bolts as well as the life of each bolt, except we'll make a kind of separate control for each. Just have a little bit more control. So we'll call this count rand seed. And so that's all well and good. Except this is always going to give us a number between 0 and 1. And since this is int, it's always going to get rounded down to 0. Because it's, between 0 and 1. It's never going to be quite 1. So just close up these spaces here. So the way we can fix that is we'll just multiply it by some amount. So say 5. So pretty much int of random number between 0 and 1. Oh, and sorry, I just want to make this all inside the same brackets. These brackets are tricky. So yeah, we have rand of this thing here, because it's all inside the same brackets. So pt num plus channel float count rand seed. And then all of this is being turned into an integer, because it's all inside these brackets. And then we're multiplying that amount by 5. And note my bad again. Sorry, I'm just kind of like wording this out of my head. We want to multiply it by 5 inside the int. Because otherwise it would get rounded down to 0 and then multiplied by 5. So it would just always be 0. So yeah, now we have, let's start with inside brackets. So channel float, count rand seed. So that is the first layer of brackets. Then we have rand function of this bit, point number plus channel float of that. So that's going to give us a random number between 0 and 1 with a controller for the seed. And then we have find an integer of this whole random number between 0 and 1 times 5. So pretty much now we have a random number between 0 and 5. So let's close that up. Sorry if that was a little long-winded. I just got a little confused there. Hopefully it still makes sense. So we'll just hit this button. I can change up the seed. So just check that that's working. Yeah, there we go. So we've got 0, 2, 3. And actually it won't go any higher than 4. Because it'll never actually reach 1 times 5. It'll just be like 0.9909. But that's alright. Up to 4 bolts is alright. We can maybe turn this number up. 6. Or we could even make this a channel float. Why don't we do that? Or we want a channel integer rather. So chi, and sorry, we'll just put it in quotation marks and we'll call this bolt count. Close bracket and close quotation marks. Click off, hit the slider. So there. Now you can see for the chi, it is only showing us integers, so you know it slides at 1, 2, 3, 4, 5, so on. So let's say we want 6 bolts as a maximum thing per layer. So cool, we've got this set up now. So we're just going to copy this bolt count attribute. We don't need the I because, you know, now that it's set up as an integer attribute, we just need @bolt count to kind of call the attribute. And we'll just plug this into the second variable in the copy. And we'll call this one rand count. Let's go up into the scatter here. And I'm just going to grab this stamp expression. So stamp equals blah, 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 just to the first bracket there. Copy that. And then I'll paste it into the force total count. Except instead of rand spawn, we're now calling that second thing we created rand count. So paste that in there. Let's go back to scene view. So check this out. Now I've basically got, I'll just turn the max number down. Hopefully it's a bit easier to see. So now you can see we've got like this kind of 1 bolt here. It's changing up by itself. Then we've got kind of 2 bolts changing. Let's change up the state of this. So yeah, now we've just kind of got these like layers of like bolts changing all together. We'll turn up the turn down the number of copies. We turn up the bolt count per layer. And you know, we can turn up the life mode, maybe make something change a bit faster. So now we're getting a bit more interesting animation here. So yeah, basically now we have these 2 nodes here, which are giving us control kind of over the number of copies, like per layer, and you know, these controls over the random seed, the bolt count per layer, all this sort of thing. So the last thing I might do is hit C again to bring up the color palette. Just make these 2 light blue. Just like that, scatter. And scatter as well, we can make that dark blue now. Oops, dark blue. Because basically it's being controlled by these 2. So the light blue basically just lets us know that these 2 are kind of the controllers of the whole thing. So yep, that's it for this time. Hope that was helpful. Thanks for watching.